Okay, we're live here with Assimilate-Python-For-Rust, and there's actually a lot of really cool stuff to talk about that I'm going to get started with. Last time we talked about the O3 library, which is actually very, very interesting. And we were able to, get things cooking there. And if I remember correctly, this is what we did, which was I was able to, inside of the main file here, make a command line tool. And let's see, look at the lib. So this was just a hello, and then I was able to get the O3 stuff working, the Rust bindings. So what I'm going to play around with today is a couple different things. So the first one that I'm going to start off with is I'm going to create a new repo here. So let's go here and let's just say new with options, and I'm going to make a new repo here. All right, that looks good. And what I'm actually very curious about is is in fact this new linter, right? So we can see here that there's this linter called rough, and if you look at this, you can see that this linter is just from 12, I think, or here we go, from 10 to 100 times faster than existing linters. So it basically shows you the power of how Rust actually can be a tool used for Python programmers. So that's what I'm going to start off with. Is I'm going to go here and I'm going to create a sample project in Python, and then I'm going to get that cooking with the rough linter first. So I think that might be a good one to play around with first here is if I just say, for example, Python 3-in, or actually, let me see if there's a virtual environment already here. Bin activate. Okay, there isn't. So I'm going to make one real quick. I'm going to say, I guess I'm going to make a new window. I don't know what happened to that one. But basically, Python 3-in, venv, tilde. So let's make a new virtual environment. We need to install virtual env, so we'll do that. And this is one of the irritations of Python to me is that just even to use Python, you actually have to install other things, which is a little bit annoying. Here we go, and let's go ahead and source this virtual environment. Okay, now the next thing I'm going to do is I'm going to make a project that is like a Python project. So we'll call this maker pyrough example, something like that. Right. So we'll go in there, and then inside of here, this is where I'm going to create a basic structure. I'm a fan of the makefile, so I'm actually going to grab a makefile from like some other project, like I have like a PyTest project that I'll just grab a makefile from. Here we go. Just because I find it makes my life easier, and we can go to here, and we can just say touch makefile. Okay. Now paste this inside. We'll also say touch requirements .txt, and then we can, instead of we have a formatter here, but I'm going to change the linter to be rough, right? So it'd be rough, and I have to follow his example here. How does he want us to follow it? So pip install rough. So let's do that first. Let's put that in here. Rough. We'll also install the formatting tool, which is Python Black, and we'll just say make install. Let's try that out. Okay, we got this thing cooking. All right, so that looks good. Now let's just make a hello file here. And for the hello, we can just do some, like this is a toy example of a Python script so I can test rough. There we go. So we'll just say hello. This is the main function. Hello world. Yeah, this is good. And we'll just say hello. So what we can do here is we can say make format, reformat it, and then we say make lint. Look at all this stuff. It says run rough on the different repos. So let's go to rough hello, or actually, what if we just say rough.py here? We just say make lint, nothing. So it's so fast, you almost don't know what's happening. So what if I just make an error and I say var equals 1, var equals var? Right, let's try that. So it didn't catch that, which is kind of weird. You would think it would catch that though, because that seems like an error. Well, let's just say var equals, how about that? Make lint. Okay, here we go. Failed to parse, invalid syntax. Okay, so I guess it's just configurable. You just have to decide how it would work and how it wouldn't work, but pretty cool. So this rough tool, you can see here again, is written in Rust. I mean, I guess it would be kind of cool to figure out how many files you could create and get linted at the same time, just as an experiment. But not bad. Run rough, explain a rule, list linter, list all supported upstream, clear any caches, print messages. But I mean, I guess I could also say, what are some other hello world things you can do? So you say rough. Oh, you say check dot. Oh, check. Okay. Well, there you go. Let's try that. So if we go make file, rough check dot. Let's try that. So make lint, nothing. Now, what if we say strict? Oh, what are the options here? So it says check path, list all the files in the current working directory. You can also be configuration. I see. So there's some other things you can do, and you can give it more things. Very interesting stuff here. So here's another example, I guess, of a command line tool here that's you could use to check out your to have linting on your code and get it in good shape. And it looks like it's extremely fast. And we can say x equals or something like that. Make lint, failed to parse, invalid syntax. Now it would be kind of cool to know what are the things that it will complain about. Like, for example, oh wow, there's also a rough auto formatter is built on. Whoa, that's interesting. Rough's linter auto formatter. So how does that? What does this thing do exactly? So does it do more than just lint? Docs. Let's see what everything it does. So we have this. See all these testimonials, but usage. Try this. Lints all the files. Wow. Or to enable auto fix. Note that Rough's pre-commit hook should run before black, isort, or other formatting tools. Huh, interesting. And rules. Oh, unused import. Let's try to get it to fail on something a little more substantial. So let's just say import OS, right? Because that's kind of a classic one, right? Make lints. There we go. OS imported but not used. So I'll just leave this as an example for somebody, and we can say that day 3 here, we can say git got Rust working, Rust linter working, called rough, and have a sample project in PyRough example, right? To test it out, run create a virtual environment, env, source it, then run make install, then make lint. So you should get this. You should get the following. Bash. We can say the error would be that. Oops. Right, here we go. Okay. Perfect, right? You should get something like this. OS imported but not used. And we can put a link to rough as well. So we can say here, rough example docs for rough. There we go. All right, so this is good. This was a huge win, I think. I think probably going forward, whenever I do Python, I'm definitely going to use rough instead of PyLint, and it's just way faster. So this was, we'll call this A, or yeah, A, or B, maybe. You got, we'll call this rough. Okay, so now let's go to B, which is, now let's try this, this interpreter, right? So this same person, if I remember correctly, let's see what else he's built. So he seems to be like a fairly prolific person. And my goal is to make Python more productive, which is pretty awesome. And if we look at his repos, what else does he got for us? Rough pre-commit. Now this is interesting. A Python interpreter written in Rust. Rust Python. Forked from Rust Python. Is this also something he's worked on? Our online demo. Well, embedding Rust into your Rust application. Let's play around with this Rust Python a little bit here next. So we could say Rust Python playing around. So next, let's go here. Let's put this inside Rust Python. So if I want to get started with this, so first I'm going to, I guess I could stay in this repo for now. So what do you do? To build it locally, to check the version of Rust you're using, Rust Python requires the latest version of Rust. Wow. So let's try this. So let's try. Do we have Rust C 166? So that's not the latest version. Whoa. So we need to do Rust update stable. So let's go up a directory, and we can see that we can add a Rust command here. We can say update. We can do this. Make update. There we go. So this is going to install the latest version of Rust. Okay. And now if we want to say version, we can say make Rust version. And it should show us everything. And it looks like, let's see, Rust C So let's double check here. Is that the right one? Rust. That's very interesting because I ran Rust up, but this one says February 7th. But if I go here, this is not February. So I don't know Rust up. Update. Rust up, update. How about that? Oh yeah, that's the latest one. Rust C. If I say which Rust C, user local bin. User local bin. What? So if I say cargo update, what happens? No, because there's no. That's very weird. I have a little bit of a weird problem here. So, which is why won't the Rust update to the local to the latest one? Rust update. Let's go here. Let's say syncing channels unchanged. Now, I wonder if because Rust is locally installed, maybe there's a conflict here where if I go to extensions or I look at my dev container, I've got some kind of a Rust version conflict. So what I don't know is if that's the issue. See, this is the latest version of Rust here. Update. But yeah, that's a good question is inside of a dev container, what's the best way to update your version of Rust? And we can Google this, I guess. How to find a Rust up version of Rust. All tools are in the Rust, and all tools are stored in. Let's see, we do that. Rust up. How about this? Let's uninstall and then let's reinstall. Maybe that can help us out. So ooh, that's weird. User local cargo bin. Yeah, this is definitely, it's something I think environment specific here that's an issue, which is kind of annoying. In the Rust, all tools are installed in cargo bin. So let's look inside of here. And let's go to this, and we'll say ls-l cargo bin. No such file inside of here. If we type in Rust up, maybe we can say Rust up which Rust C. Oh, here we go. User local Rust. Check for updates. And then we have which Rust C. So we have two conflicting versions of Rust, I think, is the problem. And that could be an issue. Oh, so annoying when you have to use vi apt get install vim. Here we go. Okay. So now if we do vim rc, vim bash rc, Go to the bottom here. We should see, I don't even see cargo in here. I wonder if it's the issue is sudo, like, I think this is this Docker container could be hurting me a little bit because this could be giving me an older version of Rust, which could be bad. That this might be something for me to look at as well. Well, kind of a tricky problem that is probably not worth getting into too much, other than maybe doing an online demo, for example. So let's just do this. So Rust Python is a Python interpreter written in Rust. The demo is compiled from Rust to WebAssembly, so it runs in Python in the browser. So you just put in your Python code, and we can just say Intel 11. There we go. Huh. Kind of cool. We have interactive shell as well. Fibonacci, FizzBuzz, interactive shell, import OS, and prints hello. There we go. Yeah, interesting. Well, yeah, I think for this, in order to fix this, what I need to do is, I mean, I guess I could try this real quick. Let's go to, let's see if I can just fix dev containers, latest, Microsoft dev container, Rust. Okay. Okay, let's see, full list. Let's see here. We're starting to migrate. We'll be publishing from here. So this one was updated 4 days ago. Oh, we need to, that might be the problem. Let's change this. If I go to here, instead of saying this, what if I just do that? Rust latest. So, and if we go here, can this change it? So if I just say rebuild, full rebuild container, let's see if this fixes my problem. That would be nice if that was one of the ways to fix this, because I think the issue here is that, it's saying Rust Python requires the latest version, and I believe user local cargo must be like a system install of Rust. So this could be one limitation of the dev container approach, but we'll find out. We'll find out here if this is the issue or not. And I guess while this is building, I could just do a little bit more searching and just say how to uninstall system Rust. Go to the program. How to uninstall that was installed. How to uninstall Rust for Debian and replace with Rust up. Perl. Oh, Rust up self uninstall. You can do that. Oh, sudo apt remove cargo. Now this could be the issue, and I need to take a look at that next. Oh, we're back here. Okay, so if I say which Rust C, right, it's in user local bin, Rust C -s version. There we go. So that was actually the problem. Well, that just goes to show you really have to be on your toes with Rust. So if I say get status here, I'm glad I've actually sorted this out. And I can say .dev container. We can add all the stuff in. git commit adding fix for latest versions of Rust. Right, so this is probably for Rust because what I'm hearing is it updates just so frequently that you probably do want to do Rust latest like this so that you get the latest version. Okay, so what do we do here? So I'm gonna, it says to build it locally, but what if I don't want to build it locally? Do I have to build it locally? Which seems like a lot of work, but I guess so. To build it locally, Rust Python. Let's do that. So I'm going to git clone. Oh, whoops. Do that. Git clone. Right, Rust Python. And now I'm going to cd into it. And what do we do next? We do, you can change into it and run the demo. The release is needed to prevent Stack Overflow on Windows. Okay, well, I don't need to prevent Stack Overflow on Windows because I'm not on Windows. I'm going to just say here, wait, note, I had to fix the Docker file to use latest. And I'm going to put this into the README. There we go. That. And then next, checkout. So I did this, git clone. And then we're going to do, we don't need that. Cargo run demo closures. And we're going to do that. All right. Kind of weird, actually, that it says it's installing these components because it's already installed. But okay, it's going through. It's updating everything here. Now, this is one of the reasons why it's kind of nice to have a big box when you're working with Rust, right? So you can see here, this is a 16-core box, and I'm taking down all the cores are basically being used here to work, which is nice, right? And we can see it's a busy machine here. Let's take a look, right? Look at this. It's a multi-threaded compiler, which is pretty slick. So it can use a big box. So Rust actually is a language that it probably is in your best interest to have the most powerful possible machine. So in the case of a Mac, for example, yeah, maybe get the latest Mac because you can have multi-threaded compiler that will saturate all the cores when you're building things. So I'm going to try this actually locally on my Mac as well. To just see what it would do. Actually, I think that would be kind of a fun one to play around with. And I think I can share that actually. Right after this, I'm going to try it again on my Mac and we'll share it and we'll see what happens. So you can see this thing's cranking, right? It's using here, we have basically 20% of the CPU now, 30%. So once that's built, we can then start using an interactive shell. Wow, then you can install pip inside, which is weird. Wow, this is an interesting little tool. Okay, so it worked. Okay, so that's cool. Now the next thing that I will do is, we'll put this here, right, is let's install pip. Let's install pip. So install pip, which would be this. Rest Python install pip. Wait a second. Once you've installed, oh, you can also install and run it like that. Okay, so we need to do this first. So we need to do this, right? Let's say Cargo run, cargo install. Oh, I guess that's a second way of installing it. So we're doing both. Okay. Rust Python. Building. Okay, so now that that's working, I should be able to run. Oh, install requires Rust Python be built with. Oh, features SSL. Well, they forgot to tell me that. So install. Let's try that. Dash git. Now, do they say that? Huh. If you'd like to. And then we would say dash dash features equals SSL. Well, that was easy. Let's do that. Let's put this command into there. So it's going to reinstall this with the SSL feature that I guess allows us to use SSL with pip. Yeah, this is definitely pretty interesting stuff. I mean, I can see quite a lot of stuff to do with this Rust Python interpreter, especially the WebAssembly. I think is a very cool technology. So let's let this thing finish here. And we only have a little bit more to do. Okay. There we go. So now let's install pip. Wow, pretty crazy. And then how do we test? So I guess why would I do that? Because I would want to just say Rust Python and then pip install, maybe pip install pandas. I don't know. I don't know exactly what that gets you yet. Like, what is how would once you've installed it, you can install pip. But then how do you install packages to compile embedding? Huh, interesting stuff here. So, well, that was kind of fun to play around with. I mean, I guess I could try one last thing as well, which I wanted to just show real quick, is that let's see if I can change the screen I'm sharing and share instead my whole desktop, this one, entire screen. Let's try that. And then if I open up like like this, there we go. So we can see my Mac here, and we can also do CPU history, right? So you can see this is this is the newest machine you can get, right? We have 12 cores. That's probably the thing that's the most interesting is this. And then if I go side by side here and I open up a terminal and I say here, I would just go open up a terminal and I say Rust up, just make it bigger like this. We say Rust up, update stable. So it's update, latest update. Okay, so it's going to install the latest update on my machine here, which is a M2 Max, right? So this is a right Apple M2 Max, 64 gigs of RAM. So next up here, what can I do? I can actually do that command, right? So let's go to a directory I put in source a lot, and we'll git clone this thing. And then what's the next thing they wanted me to do after git clone is they want me to cd into it. So we'll cd into this. Whoa. And then we just can do essentially cargo run without the release. I don't think we need that. Let's get rid of the release. So this will do the multi-threaded compilation. So this does actually, again, as I mentioned before, show why you may want a big machine if you're working with Rust, because it actually, when you compile, it is actually compiling against all of the cores that are available. And the latest M2 Max actually have 12 cores, which is for a laptop is pretty incredible. And so I'm gonna fetch this real quick, and we'll see what happens when it does a compile. Let's see here. Kind of hanging a little bit, which is weird because I have actually fiber network connection, so I'm not sure why this is taking a little bit of time. It seems like it's actually hanging a little bit. Updating creates data index. Yeah, interesting. I've never had this actually happen before with cargo, but I could do it again. Just maybe kill this real quick. And let's just try it again. Yeah. Maybe there's something in particular that's it's trying to get and it can't get access to it. This is strange. Yeah. Well, that's good enough though. I got at least the process cooking with Mac, but the main takeaway was we got this stuff. We got this stuff cooking here, and I'll check it all in. Once it gets status. Yeah, I think we're good to go. So thanks for hanging out with Rust Python, and I'll be back in a couple of weeks to talk a little bit more about it.